we're going to be subtracting mixed numbers. These are mixed numbers that have the same denominator, so 5 in this case. Now I always like to start doing these problems by modeling the situation here. And if you are modeling 2 4/5, you'd need 2 of the holes rods and then 4 1/5. So 2 4/5 looks like this. Now if you watch the addition video, you know that with addition problems we would model both of those numbers, but I don't really want to model 1 2/5 here because that's not what subtraction is. Subtraction is that I'm starting with this amount and I need to subtract or take away that amount. The great news is that just like with adding mixed numbers, we can subtract in a similar fashion. Just think about subtracting the fractional parts first. So to show subtraction, that we're taking it away, I'm just going to flip these over here. So I subtracted 2/5 from the 4/5, and I have 2/5 remaining. And then with the whole numbers, I have 2 wholes, and I'm subtracting 1 away. So I have 1 whole remaining, and now I'll take away those that I flipped. So you can see 1 2/5 remains. Now, because of how subtraction works, I actually prefer to draw out my models. I find that better when I'm doing a model for subtracting mixed numbers because I've got my 2 wholes here. Now I need to make a model of 4/5. It's 1, 2, 3, 4/5 there. And I like this model a lot better because instead of flipping over the tiles, I can just say, okay, I want to cross out 2/5 because I'm subtracting those 2/5 away from those 4/5. And then I have these 2 holes, and I'm subtracting 1 hole. And then whatever is left, 1 hole and 2/5, gives me my difference. So I really like drawing out those models. So now let's try another problem. We've changed the denominator to 6, but there is going to be a little twist in this one. I've already started by modeling 3 wholes and 2 6. I got my 3 wholes, my 2 1/6 here, and now I need to subtract 1 whole and 5 6. Well, we started with the last problem just subtracting the fraction. So let me take 5 6 away from 2 6. Oh, well, wait, I can't do that because I only have 2 6. I need to subtract 5 6 from that. Well, this is where it's really helpful to remember that each whole is actually just a collection of fractions beneath. Our denominator is 6, so each whole is just a collection of 6 sixths. So now I have enough 6. I don't just have 2 sixths, I have 2 6 plus another 6. I have 8 sixths where I can subtract 5 6 away. So I subtract 1, 2, 3, 4, 5 6 away. Now I have 3 6, and then subtract 1 whole away. And now I have 1 3/6 remaining. All right, so let's go through that scenario again, but now let's make some annotations over here in our equation. So we have 3 2/6 subtract by 1 5 6. So since we don't have enough sixths to subtract 5 6 away, we had to take one of these wholes and basically exchange it, trade out that whole for 6 sixths. So in our equation, I can cross out the 3 because we no longer have 3 holes. We only have 2 holes left. And we brought 6 sixths over here to mix with the 2 6 we already have. So 6 6 plus 2 sixths, now we have 8 sixths. We have 8 sixths, 2 wholes, and 8 sixths. Now we can do our subtracting. 8 sixths minus 5 sixths. Take away those 5 sixths, and that gives us 3 6 that we're left with. And now over on the whole numbers, 2 wholes, which you can see here, take away one of those wholes. And now we're left with 1 whole and 3 sixths. Now, if this reminds you of borrowing, that's great. I mean, you've been doing this for a few years now. If you're trying to subtract 34 from 51, you start in the ones place and you try to subtract 4 ones from 1 1. You can't do that. So you have to borrow. In this case, that 5 tens becomes 4 tens. Now, when you're borrowing 10 ones, so that's why this one becomes 11, because you're adding 10 ones over here, and now you can do your subtraction as usual. Now, with fractions, you just have to pay attention to what is the denominator, and since the denominator here was 6, when I borrowed from that whole, I needed to bring over 6 sixths. Okay, so one final example of this. Again, we've changed the denominator to fourths, so 4 fourths will make up one whole. We've got 3 wholes and 1 fourth, which I've modeled here. We're going to subtract 1 and 3 fourths. So again, if we're looking at the fractional parts, I cannot subtract 3 fourths from 1 fourth, so I'm going to have to borrow from one of these wholes, but one of these wholes is actually 4 fourths. So now I'm left with 2 wholes, and I'm bringing 4 fourths over here, 4 fourths, and I'm adding it to the 1 fourth that I already have, so you can see I've got 5 fourths here now, 5 fourths. 5 fourths, subtract my 3 fourths, 1, 2, 3. That leaves me with 2 1 fourths. And then now I have 2 wholes, as you can see, and I need to subtract one of those wholes. There it goes, and I'm left with 1 whole. So 3 and 1 fourth minus 1 and 3 fourths, I'm left with 1 and 2 fourths. Now finally, I know you're unlikely to have these fraction tiles where you're at, so I want to show you how to solve this same equation, but by making drawings. So you'll want to model the 3 wholes and 1 fourth. I've got my 3 wholes here, and I'm going to make 1 fourth. I'll label it 1 fourth. Okay, so now I've got my 3 wholes and 1 fourth here. I'm subtracting 1 and 3 fourths. So when you're subtracting, you want to cross out 3 fourths. Oh, I can only cross out 1 fourth. So I need to take one of these wholes and split it into fourths. 4 fourths would make a whole. Each of these are now 1 fourth. And so no longer do I have 3 wholes. I only have 2 wholes. And then I brought over, that made 4 more fourths. So now I have 5 fourths, and I can subtract 3 fourths. So 1 fourth, 2 fourths, 3 fourths that I've subtracted, leaving me with 2 fourths in my picture. And then now on the wholes, I have 2 wholes. I need to take 1 away. Now I have 1 and 2 fourths remaining. There we go. Subtracting with mixed numbers with like denominators.